All right, here are solutions to perfect problem 7 for Math 60. We're given two linear equations and asked to find their x and y intercepts. So maybe let's first find the x-intercepts. So the x-intercepts happen when y equals 0. So if y equals 0, how should I do this? Equation 1 would become 3 times 0 plus 2x equals 18. And equation 2 would become 2 times 0 plus 6 equals 3x. So I want to solve both of these. This top one, I get 2x equals 18. And if I divide both sides by 2, I get x equals 9. And this bottom one, I get 6 equals 3x. So if I divide both sides by 3, I would get x equals 2. And then we can find the y-intercepts in more or less the same way. The y-intercepts happen when x equals 0. So we get equation 1 would then become 3y plus 2 times 0 is equal to 18. And equation 2 would become 2y plus 6 equals 3 times 0. Alright, and then 3y, 2 times 0 is just 0, so I get 3y equals 18. And if I divide both sides by 3, I get y equals 6. And over here I got 2y plus 6 equals 0. So if I subtract 6 from both sides, I get 2y equals negative 6. And if I divide both sides by 2, I get y equals negative 3. So, alright, I got all the points up here. X-intercepts and y-intercepts. Now I want to find the slope of each equation above. So maybe over here I'll do equation 1. One of the points that I have in equation 1 is when y equals 0, x equals 9. So for equation 1 I have 2 points. One of them is at 9, 0. And the other one for equation 1 is when x equals 0, y equals 6. So 0, 6. And so my slope is the change in y, y2 minus y1 over the change in x, x2 minus x1. So if I give these points a name, maybe I'll call this one x1, y1, and this one x2, y2. Then I can just plug in all the points. Y2 is equal to 6, y1 is equal to 0, x2 is equal to 0, and x1 is equal to 9. So I get 6 divided by negative 9, which can be written as negative 2/3, is my slope in equation 1. And same idea for equation 2. For equation 2, I got 2 points. My first one is when x equals 2, y equals 0. So I get 2, 0. And my next one happens when x equals 0. I get y equals negative 3. So again, let's call this one x1, this y1, this x2, and this y2. I can then figure out the slope by plugging into this formula here. Y2 is equal to negative 3 minus y1, which is 0. X2 is equal to 0, and x1 is equal to 2. So what I get here is negative 3 divided by negative 2, which I can write as just 3/2. Okay, so I have two slopes. Now it wants to know, are these lines parallel, perpendicular, or neither? These are perpendicular. And the reason why, because negative 2/3 is the negative reciprocal, I think I spelled that right, of 3/2. That is, if you take one of the slopes, flip it upside down, and add a negative sign, you get the other slope. So they're perpendicular. All right, I guess finally we want to sketch these two lines. Looks like I was using blue earlier or no, I wasn't. I've been consistent. All right, let's first sketch equation 1. So equation 1, we know that when x equals 9, y equals 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Barely fits on my graph here. 1, 2, 3, 4, 7, 8, 9. Yeah. So here is my x-intercept for equation 1, and my y-intercept is up here at 6. 1, 2, 3, 4, 5, 6. Could even label these points. This guy is 0, 6, and this guy out here is 9, 0. And I can draw a line between them. It's not easy to do, but I can try. It would go something like that. It's actually not too bad by my standards. End up with something like this. And this is equation 1. So what I did here is I plotted the x-intercept, the y-intercept, and then I connected them with a straight line. And now I'm going to do that again for equation 2. Equation 2, I know that the x-intercept happens when x equals 2 and y equals 0. So that's this point right here, which is at 2, 0. And the y-intercept is at 0, negative 3. So 0, 1, 2, 3. And what I can do is try to connect those guys with a straight line. I think it should look something like this. Good enough. And so this right here is equation 2. And like we suspected, like we came up with in algebraically in part C, we said they should be perpendicular, and it does kind of look like they're perpendicular here. So I guess that's the end. That's the end of this perfect problem.